My name is Marton, responsible for the orchestration area in Ericsson. And today I will touch upon two aspects. Our sort of road to automation, how we can basically start small, create a automation framework, and then gradually increase and add more components and reach the highest level of automation which you need to achieve network slicing, which is also the base for the introduction of 5G services. We created this framework because it's very concrete. It contains very concrete steps in both technical terms, introducing components in the network, but it also includes very concrete organizational and business transformation steps. The automation starts basically at the bottom on the virtualization area, and I think most of you have already done at least some virtualization, or at least started the journey. And you have probably realized that you do have some gains in the TCO by aligning the hardware in the data center. But due to the complexity of a virtualization and running basically a physical and a virtual network in parallel, you go down in terms of total cost of ownership. And the way how to mitigate that is to start introducing automation aspects. And the first step in this sort of ladder, which you can see as climbing from 1 to, let's say, 9, is to start with VNF lifecycle management. And what it means is that you automate the typical operations like instantiation, termination, healing, scaling, and also upgrade. And we, of course, provide ready-made automation scripts for Ericsson core applications, but we also provide a framework and follow the ETSI standard to be able to automate any sort of VNF out in the market. We have deployed in the, let's say, past 3 years around 200 different VNFs, some from the IT side, mainly focusing on SD-WAN and virtual CPE, so load balancers, firewalls, SD-WAN optimizers, and so on. But we have also deployed other, let's say, non-Ericsson telco applications from Nokia, Huawei, HP, ZT, etc. So we have a vast experience in sort of managing the VNFs on the lifecycle management level. And it includes, once you sort of reach this step, the typical operation takes minutes. If you do this manually, it could take days. So it's, of course, a very big saving as a TCO. The second step is that, okay, now I have automated the lifecycle management, but when it comes to testing, that's the biggest sort of area which you do still manually in many of the networks. And through the cooperation initially with Verizon, when we introduced their SD-WAN optimization and their SD-WAN project, we have realized that we have to automate the onboarding and testing. So we created a product which covers the testing of SD-WAN services, but then we also added IMS, packet core, IoT, mobile broadband, and basically VoLTE services as well, so that when you start creating your CI/CD, continuous integration, continuous deployment processes, then you can add automation into that step in terms of taking the VNF, putting it in your test environment, running a number of test cases, and if it passes, it goes into live operation. If it doesn't pass, then the automation engine collects all the sort of logs and faults and give it back to the vendor. And this, of course, shortens the time to market for any VNF introduction. The second sort of big step is when you move into a data center transformation. So that's an operational step as well, introducing an internal organization to host the NFVI environment. And a lot of our customers have taken this step Telefonica, Verizon, Swisscom, to name few. And the base to sort of take this step is to introduce an orchestrator. The orchestrator is connected then to distributed data centers and have insight into all the VIM zones and have a single pane of glass from which you can operate the distributed virtual resources. In your previous departments, like mobile broadband, communication services, instead of owning real hardware, they work with virtual resources and only a part of the, let's say, data center resource. It's also the base to sort of add automation steps on top. Introduction of data center SDN is the next logical step. Ericsson has its own based on Open Daylight, but we work with Juniper Contrail as well. And again, it's a massive time saver because we automate the connection of VNFs to each other, the connection of VNFs to the physical environment, and also the virtual overlay network setup towards the data center gateway. Usually networking in the telco space is very complex, and by automating this process, we are typically measuring number of days in upgrade processes. Number 5 is closed loop automation. I will talk a little bit more about that. We have just recently acquired the company, Xenix, which is focusing on gathering all the data from applications and from the data center environment. And then we have a way to detect faults, and then the orchestrator, based on a policy engine, automatically corrects those faults. Basically, if it's overloaded, we do scaling. If something crashes, we can do healing or migration of VNF into another part of a data center. And this is, of course, a prerequisite to be able to run a large number of services in parallel. Again, we have done this step with Verizon, for example, because when they have introduced SD-WAN, they have created a number of services, one per large enterprise, and to operate, let's say, 50 or 60 services in parallel, you of course want to have automation in the operation of the networks. The third sort of big step in this journey is when we take this, let's say, data center transformation to the edge. Edge can be the mobile edge, or it can be an enterprise edge, or in our case, we have also adding capability to be able to orchestrate applications in a public cloud. And the base for this step is the service orchestrator. Probably the biggest, let's say, time saver, the biggest improvement in the automation, because now instead of working with individual VNFs, we work with a catalog of services. Again, Verizon have done this step, so they have modeled their SD-WAN virtual CP services, created sub-elements which we put in a catalog. We have also done this step for 5G core, modeling the IoT and mobile broadband services. And I will make an example to show you what it means in practice. But in essence, you instantiate and create a complete service in one go, configure it and put it in live operation. And that's the base to sort of build on top, adding cloud-native capabilities like Kubernetes, adding public cloud connectors, and then going to our goal to be able to be ready to potentially run hundreds of services in parallel. And I will show a little bit what we are doing in terms of network slicing, addressing a new business opportunity with private LTE and network slices together. The portfolio behind this automation journey is a dynamic orchestration solution. In the center is the Ericsson Orchestrator. It contains two logical elements, a typical, let's say, cloud management function with an NFVO, VNF management and configuration engine. And on top, there is a separate module for service orchestration And we have also added a capability to automatically provision WAN, the transport network between data centers and between data centers and the edge. The surrounding components support the solution. Onboarding and test automation, I already mentioned. Inventory, it's now becoming very important because service orchestration relies on an inventory to be able to understand what needs to be deployed and what is already available in the network. To be able to do that needs an active inventory inside. Then assurance, in our case it's Phoenix, provides closed loop. And analytics is a way to look at events, look at what's happening in the network and predict instead of doing just sort of policies based on thresholds. Analytics helps us to understand and plan operations in head. If you look at what we can do with this portfolio, so we can orchestrate a service between the edge being an enterprise or an edge of the mobile network, going through physical resources, virtual resources, but also through cloud-native applications now running on Kubernetes. So we have added lifecycle management based on Helm charts to the VNF management component so that we can orchestrate microservices-based applications like the Ericsson 5G packet core. Currently, Kubernetes clusters only work in practice on a VM environment because we don't have a really robust networking which can connect these Kubernetes clusters to the physical world. So we use the automated networking in the VM layer. So on top of that, there is a Kubernetes engine with the microservices. Of course, in the future, we are expecting that Kubernetes reaches maturity so that we can run it on bare metal as well. And then, as I said, we are also adding, again, something which we are doing with Verizon, a capability to orchestrate applications in a public cloud, in this case in AWS as well. I wanted to give you one example so that you have a feeling what does it mean to orchestrate an entire service. It starts with an order from the BSS to create a new network service, and that service is available already in the catalog. Then the service orchestrator talks to the inventory to understand what is already deployed and what needs to be instantiated. And then comes the order to the NFVO engine, which then basically creates the missing components, the missing VMs in a distributed network environment, connects them using SDN, creates the virtual links between data centers, and also, if there is a need, creates a link to the public cloud. What's also very interesting is that once this is done, the service orchestrator pushes down the configuration files. So here we can automate the day 0 and the day 1 configuration so that the service components are fully up and running and configured. We can push the YANG models, in this case, to the domain manager, if it's a telco environment, or push these YANG models directly to the VNF, if it's a simple VNF like a load balancer or a firewall, which doesn't have a domain manager. And once the service is basically ready, we use the test automation engine to run end-to-end the tests. And then finally, what we have added just recently, to also automate the transport. So a higher order SDN controller talks to the transport components to create a link between a data center and the access, and also between the data center sites. And with this, you can basically deploy a service roughly in a little bit over an hour, depending on the complexity of the service, and it's fully operational, ready for consumption. And this is what we can do today. This is what we have already sort of put in live operation with Verizon. We're also doing the same thing for mobile services like IoT and mobile broadband and so on. A bit about service assurance and the reason why we acquired Xenix. In the operation, once the service is live, we are doing this, let's say, closed loop, monitoring, understanding what's going on, and then taking corrective actions. Again, this is live in few cases. Verizon is being one of them. And it, of course, saves a lot in terms of both operational cost, but also time. Because when the error occurs, most of the errors can be sorted out automatically. Now, before I move on, so the base for this high level of automation is what we need in order to take the next step. And the next step, what basically 5G is promising, that now we can address new industry verticals. And there are so many interesting opportunities in manufacturing, in public safety, in transportation, and so on. And we have done a number of trials, one with Swisscom, using a combination of private LTE, basically a radio deployed locally on the manufacturing site, and the network slice automatically created in their central network environment. These use cases are, of course, now possible to achieve with 5G. A lot of them are possible to achieve actually with LTE already. To name few, which we actively work with, is industrial application, industrial control, refreshing the public safety, like let's say the walkie-talkie from police and public safety services, provide capability to automate, let's say, the train monitoring, the train surveillance, and so on. The sort of solution behind this to address the industry verticals and to address them is the combination of putting the radio locally to, let's say, provide a network coverage for, let's say, a manufacturing site or a construction site. But instead of doing everything just in the local environment, let's say now the number 3, the T3 example, is the most popular. We deployed the absolute minimum, the local LTE, like basically one small base station, dot in the case of Ericsson. Then we deploy a network slice in an automated fashion centrally in the network environment, creating the packet core, creating the UDM, creating the communication services in the central environment. Basically doing the best of both worlds to improve the time to market and decrease the cost. So of course, we are very excited to sort of move into this 5G world when you can also expand the business potential beyond just connectivity. And the base to really get there is the high level of automation. Because if you cannot automate those 4 or 5 services you have in the network today, you will not be able to potentially have hundreds of services towards industry verticals in the near future. So thank you very much. I also open up for questions. I think we have maybe 1 minute. Okay, excellent. 4. Fantastic. Do you have any questions? All clear? Okay.
Yeah, go ahead. What are the most common services that operators are asking for to be orchestrated and deployed?
So it's a very good question. So our customers are in sort of different phases. There is a very common step now to take the SD-WAN virtual CP introduction on the enterprise side. And the second sort of very common journey is to start the data center transformation of the packet core. And why these two? Because by able to automate packet core, we take an active step towards IoT, we take an active step towards introducing network slices for industry verticals. So operators are taking these two steps actively and also preparing for the 5G packet core introduction, where virtualization is not just recommended, but absolutely necessary. Any more questions? There's one more there.
Thank you for your presentation. I was wondering if you could address onboarding of virtualized network functions and just give us a sense of what that's about and how long it takes.
To introduce virtual network functions.
To onboard them, the new ones, the ones that aren't in the catalog already?
Yes, so once the onboarding step is done, meaning that the image is prepared and it's in the catalog, if it's a virtual network function, then it's about that we're going into an instantiation step, and that usually takes somewhere between 2 to 10 minutes, depending on the complexity of the VNF itself.
But how long does it take to onboard the VNF? Is that process getting better and faster?
So that's an excellent question. So if I go back to my, let's say, first slide, so if you don't have any automation in place, then it usually takes sort of several weeks, because then you need to take manually the VNF, you need to manually review the hot files, you don't have any test automation, so you need to do some manual testing. So it takes roughly sort of several weeks. But if you have, let's say, an automated onboarding, automated testing, a VNF manager which can automate the typical lifecycle management processes, then we are talking about basically a day max.
Thanks.
Okay. Excellent. I think we are done. So thank you for your questions.